Hey guys, all right, so Unit 2, we're on Lesson 7-1. So this handout is obviously handwritten, and so we're not using the book notes this time, but here we are. So it says for a warm-up, we're going to use composition of functions. You learned about composition back in Math 2. We're going to let f of x equals 3x minus 2 and g of x equals x plus 2 over 3. And we're going to evaluate each of these. So first, f of 1 means that we have to plug a 1 in for x into the f of x function, because that's its name. It's the f of x. So that would be 3 times 1 minus 2. 3 times 1 is 3. 3 minus 2 is 1. So f of 1 equals 1. Okay. F of negative 20. So that means we have to plug in a 20 into the f function. So 3 times negative 20 now, minus 2. That would be negative 60 minus 2, so negative 62. F of m means we are going to plug in an m for x. So that would be 3 times m minus 2. Whoops, I didn't need parentheses there. What am I doing? Well, this is just going to be a 3m minus 2. So it's pretty much the same thing, but instead of f. All right, f of smiley face means that we're going to plug in a smiley face for x. So 3 times, why did I put pi? 3 times smiley face minus 2. The smiley face started to look like a pie to me. Like pi, the symbol. Now this one doesn't have anything in it, so I'm going to put in a symbol. One of my favorite symbols is a heart. So f of heart, so I'm going to replace all the x's with a heart. So that would be just 3 times heart minus 2. And then f of g of x means that we are plugging in g of x into f of x. So g of x is the x plus 2 over 3. So we're going to plug that in for all the x's in f of x. So that would be 3 times x plus 2 over 3 minus 2. Well, these 3's will cross cancel. So I have x plus 2 and then minus 2. Well, 2 minus 2 is 0, so this equals x. All right, now let's work on the g function. So g of 1. Now this time we're working with the g of x function, so we're going to plug in a 1 for x. So that would be 1 plus 2 over 3, which is 3 over 3, which equals 1. Then g of negative 62 means we're plugging in a negative 62 in for x in the g of x function. So that would be negative 62 plus 2 over 3. Well, negative 62 plus 2 is a negative 60 over 3. And negative 60 over 3 equals negative 20. Oops, guys can't see. And then g of f of x means that we are plugging in f of x into the g of x function. So f of x is the 3x minus 2, and we're going to plug that in for the x in g of x this time. So I'm going to replace the x in g of x with a 3x minus 2, and then there's plus 2 all over 3. Okay, anytime you plug something in, you need to put parentheses around it. All right, so 3x minus 2 plus 2, well, these 2's are going to cancel, so we'll just have 3x over 3, and the 3's cancel, and all we have left is an x. Hey, when we plugged in g of x into f of x, we got x. And when we plugged in f of x into g of x, we also got x. So that is going to mean something to us, something important. So since f of g of x equals g of f of x. These are inverses of each other. Okay, so inverses of each other. Inverses is what this lesson is about, where it's about inverse functions. Okay, so anytime you plug a function into a function and you get x, and then you do the reverse, you plug the other function into the second function and you get x. That means that they are inverses of each other, and that works for any functions. So anytime you do these operations and you get x for both, they are inverses of each other. All right, so let's take a closer look, like it says there. We're going to graph these same two functions, and it says in two colors. So I'm going to use this dark purple and red. These are my two colors. Okay, and I'll let f of x be this purple color, and g of x be this red color. All right, so let's start with f of x. This is a line. So remember in the warm-up the other day, we did lines. And let's see, the y-intercept is a -2 because we need to be thinking y equals mx plus b. So you always start with the y-intercept. It's at a -2. So we'll plot a point down there at -2. And then the slope is a 3. So we're going to go up 3 over 1. So up 1, 2, 3 over 1. Do it one more time. 1, 2, 3 over 1. And we have enough to make a line. I need to use a ruler because I suck at drawing straight lines freestyle, so I'm not going to even chance it. Make my line all nice and pretty. Okay, so there's f of x. And I don't need to label it f of x because we're color coding it. All right, g of x, the 1/3 x plus 2/3 is the same as x plus 2 over 3. All they did was they separated the fraction, the 1x over 3, and then the 2/3. Okay. All right, so this is also a line then, y equals mx plus b. And the b is a 2/3. Okay, so we're going to have to get as close as we can to 2/3. So 2/3 of the way before 1 is approximately going to be about right there. So there will be my y-intercept. And my slope is 1/3, so I'm going up 1 over 3. So if I go up 1, then I'm at the next 2/3 spot. So I'm right below the 2, but then I'm going over 3. 1, 2, 3. Okay, and I only need 2 points to graph a line, so I'm going to stop there. All right, so I have my graph. What do we notice? Well, I would have you guys ponder this in class if we were in class together, but I do want to point out something that is going on here. Notice the diagonal going right through the diagonal of the graph. Okay, I made it a little crooked, but it's all there. Okay, so basically, if I were to think of a reflection, the red line is being reflected across the yellow dotted line, and it's the purple line. And this top part of it, it's being reflected over the yellow line, and it's the red line. So what do we notice? Well, they are reflections. They're reflections of each other. And they reflect across, well, what is the equation of this line? When you're going up 1 over 1 all the way, that means that this is the line y equals x. X. Where did we see that before? F of x, or f of g of x, it's the same as saying y equals x. Right? That's just function notation. So that's why they're inverses of each other, because they are reflected across that same line. Okay, so this is how you do it graphically. Well, how do we do it algebraically? There's got to be a way we could do this with some algebra. There is, and I call it Freaky Friday. I know it's not Friday, but the day that you're watching this lesson is a Thursday, which technically is our Friday for the class. So Freaky Friday. So you know how the mom and the daughter switch places? Hopefully you've seen that movie. Well, you simply switch the X and Y. It's so easy. You guys are going to like this. I promise. But you got to give it a shot. The only way you guys are going to learn stuff is by doing it. All right. How do we find a function's inverse is the next portion of this segment. So how do we do this? Number one, find the inverse of the function f of x equals 2x minus 4. Step one, change f of x to a y, because it's the same thing as y. So let's let y equal f of x. This is step numero uno. We have to do this step, because how can we switch x and y if there's no y? We got to make sure that we change out the function notation for the regular notation. Step two, Freaky Friday. So switch x and y. Then step three, solve for y. Okay, so let's do this. Step one, we have to change out the f of x for a y. So y equals 2x minus 4. Okay, that's easy, right? Step two, switch x and y. Okay, so instead of y equals, that'll be x equals, and instead of 2x, that'll be 2y minus 4. And then step three, solve for y. Well, to isolate the y, we need to add 4 to both sides. So we'll get x plus 4 equals 2y. And then we're going to need to get rid of that 2, so we're going to have to divide everything by 2. Okay, so there are 2 ways we could write our answer. Y equals x plus 4 over 2, or you could split the fraction and put y equals, that's a 1x, so 1/2 x plus 4 over 2 is just a 2. Okay, I like this method better, but this one is just fine as well. Okay, but we're not done yet. Step 4, we need to change the y back to function notation. So to write an inverse, so now y is going to equal the inverse, you have to put f to the -1 power of x, and you read that f inverse of x. So that -1 on the f means that you're taking an inverse of the function. Okay, so then the final answer will be f inverse of x equals, I'll just write it like the one that I like, 1/2 x plus 2. Easy peasy, but you've got to try it out. Okay, so in the Edpuzzle, you're going to be asked to do these on your own, and you'll check your answers, okay, just so you know. So number 2, this is how we do it. Change f of x to a y. Okay, then Freaky Friday, switch places for the x and the y. So x equals -3y plus 8. Okay, then we have to solve for y. So subtract 8. So we'll get x minus 8 equals -3y. We still need to get rid of that -3, so that means we're going to need to divide both sides by -3. Okay, so my answer then will be, remember, we need to change it back to function notation, so f inverse of x equals, I'm going to have 1x over 3, so 1/3 x, minus 8 over 3, so 8. Second phone call during this lesson. My goodness. Okay, so there it is. Okay, and just to reiterate, or you could write it as f inverse of x equals, you could just put x minus 8 over 3. You could write it this way too. Sometimes you are going to see it this way, but sometimes you're going to see it this way also. This is the way you see it the most, which is why I lean towards this the most, but sometimes you'll see it like that too. And you need to recognize that they're the same thing. All right, next one, number 3, h of x. So let's see, we need to first change out the h of x for a y. And then Freaky Friday, we got to switch their places. So we'll get x equals 2/3 y minus 5. And I'm going to bring this up here because I'm running out of room there. So the last problem took up a lot of space. All right, and we need to solve for y. So I'm going to need to add 5 to both sides. So I will have x plus 5 equals 2/3 y. And we need to get rid of that fraction. And I know that fractions can be a lot of people's arch nemesis, and they shouldn't be. It's just they're misunderstood. So here's how we can get rid of a fraction in front of a variable. You just multiply by its reciprocal. But whatever I do to one side, I must do to the other. Okay? So that is the only thing. And then we're going to have to distribute that 3/2. So 3/2 times x is just a 3/2 x. 3/2 times 5. Well, 3 times 5 is 15. And 2 times 1 is 2. So 15/2 equals, these completely cancel, which is why we multiplied by the reciprocal. So y equals that. Okay, we're ready to go. Now we can change it back to function notation. So h inverse of x equals 3/2 x plus 15/2. There it is. All right. When is a function's inverse also a function? Okay. Because sometimes when we find the inverse won't necessarily be a function. Well, what does it mean to be a function is what's next. That's how we can tell. So how do we tell if an equation is a function? Okay, so for example, we have y equals x squared. So what do we normally tell if a function, or if a graph is a function? Well, remember the pen rule? You hold your pen over the graph, and as long as it only crosses through the graph one place at a time, it's a function. What test is that called? When we draw vertical, or you can even draw vertical lines. It's only crossing through right there. If I draw a vertical line right here, it's only crossing through at one place right there. If I draw a vertical line right here, it's only crossing through the vertex there, and so on. It's only crossing through one place at a time. This test is called the vertical line test. You learned this back in the day. It's just probably been a quick minute before you've done it. Okay, so for f of x to have its inverse, f inverse of x, be a function, f of x must pass both the vertical and, what do you think the other test it needs to pass is going to be? If you thought horizontal, you're right. So both the vertical and horizontal line test. Okay, so does this parabola pass the horizontal line test? Well, if I were to draw a horizontal line through the graph, it's going to hit right here and right here.
Mama.
So Because it doesn't pass the horizontal line test, that tells me that its inverse is not going to be a function. The parabola itself is a function because it does pass the vertical line test. But I can look ahead and be like, oh, but you know what? It doesn't pass the horizontal line test. So when I find its inverse will not be a function. So if it fails, what do? We can restrict the domain to fix it. Okay, so we can work around it. We can fix the domain. Remember, the domain has to do with the set of x values that's being used by the graph, and the range has to do with the y values that are being used by the graph. So all we have to do to make sure that the inverse is a function is restrict the domain. So put some of it on timeout pretty much. Okay, next page. Says to find the inverse of each function, determine the domain and range of f of x so that both f and f inverse are functions. Okay, so let's start with what we have here, number 3. We have x plus 3 quantity squared. Okay, this is because it's squared, that means this is a parabola, a quadratic. Okay, and it's in vertex form, so we know that this has to do with a shift, and since it's a plus 3, that means it was shifted to the left 3 units. There's no shift up or down because there's nothing there, that means it was a 0. Okay, and so let's take a look at the graph of this real quick. We can sketch a graph super duper quick. So shift it to the left 3. 1, 2, 3. So the vertex would be at negative 3, 0. I'm just faking the slope of it. Okay. So the parabola's sitting over there. Does it pass the vertical line test? Well, yeah, it's only going to cross through one point at a time. No matter how many vertical lines I draw through it, it's going to pass. But will it pass the horizontal line test? No, because it's going to cross through at 2 points at one time. So I know that this is a function because it passes the vertical line test, but its inverse will not be. So we're going to need to fix the domain so that it works. Okay, well, let's first, before we find the inverse algebraically, let's find the domain of f of x right now. So remember, D for domain, the set of x values, R for range, the set of y values. So the domain, all right, so the domain, the x's that we're using, well, if I restrict it, I can figure out what it's going to need to be. But looking at the x's, we're looking at x's, all real numbers. And the range, the lowest value, the minimum of that parabola is at 0. So the lowest I can go on the y is 0. So y has to be greater than or equal to 0. Okay. So this is the parabola as is, the way it is. The domain uses all real numbers because we can plug in anything we want for x. The range, though, the y values stop at 0. It goes from 0 to positive infinity. Okay. So we have that. This is for now. All right. So let's take a look at the inverse. So that's where we have to change out the f of x to a y. Zoom in a little bit. And so y equals x plus 3 quantity squared. And then Freaky Friday, so we got to switch out the x and the y. So we'll get x equals y plus 3 quantity squared. And we need to solve for y. And you know what's beautiful about this? This is a quantity squared. You don't need to multiply it out. All you have to do to undo a square is square root. The root is on fire. But because we're solving for y, a variable, there's going to be a plus or minus in front of that square root. Okay, so when I take the square root of a perfect square, the y plus 3 gets to come out and flipping it around. Equals plus or minus square root of x. Subtract the 3. So y is going to equal -3 plus or minus the square root of x. You always write the number that you're adding or subtracting in front of the plus or minus. Okay, so what is this pretty much? So this tells me that the f inverse of x is equal to this. But I've got plus or minus. What does that mean? So let's do a little t-chart. We'll plug in some numbers. I can't plug in numbers that will make this negative because I don't want imaginaries. So no imaginaries, guys. Don't even think about it, okay? We're not dealing with imaginaries for any of these problems in this unit. So let's see. I can't go on the negative side. I can only go as low as a 0. So 0, if I plug in 0, square root of 0 is 0. -3 plus 0 is -3. Same with -3 minus 0. Okay? Yeah. Okay, and then if I plug in a 1, -3 plus 1 is a -2. If I go with the minus, -3 minus 1 is -4. Okay, let's see what that looks like. So let's see, I need a 0, -3, 1, -2, and 1, -4. Well, the inverse of an upright parabola is a sideways parabola. And this is why the inverse is not a function. Does that pass the vertical line test? Nope. So this is why. Now, we need to restrict the domain so that both of these are functions. Well, how can we do that? Well, if I only had half the parabola, then half of the inverse would show up, and both of those would pass the vertical line test and the horizontal line test. Okay? Or I can do the other half. If I cut off the right half, then I would cut off the top half. And those would be inverses of each other. Okay? So there are two ways that I can restrict the domain. I could either chop off half of the left half of the parabola or the right half of the parabola. So I'm gonna fix the domain now. So new f of x. So if I want to chop off the left half. So if I get rid of the left half, that means I'm using x values from -3 to the right. So I'm using x's that are greater than or equal to -3. Those are to the right of -3. Okay? The range doesn't get affected because you don't need to restrict the range. The domain is what's getting affected. So y is still greater than or equal to 0. Okay? So this would be the domain and range for f of x that we need to use. And then since we chopped off the left half, that means the negative side of the sideways parabola is getting chopped off as well. So that means we don't need the negative part. So it's just -3 plus the square root of x would be our inverse function. Okay? But we also need to write the domain and range for the inverse. Well, guess what? It's really easy. Once you have the domain and range for the regular function, you just have to Freaky Friday them to find the domain and range of the inverse function. You get to Freaky Friday everything. So I'll put it over here. So f prime of x, the domain and range. Well, we just have to Freaky Friday them, so they got to switch places. So the domain would be x greater than or equal to 0. Now let's check that. Oops, you guys can't see. So let's look at our graph. Well, look at the x's on the blue graph there. I'm starting at an x value of 0, and I'm going to the right. So x greater than or equal to 0 is true. And then that means the y needs to be greater than or equal to -3. Well, let's look at that. We're down on the y at -3, and we're only using the top half of that sideways parabola. So yeah, greater than or equal to -3 is from -3 on up. So there is my domain and range for the inverse function. So there were 3 parts we had to find here. The inverse function, restricting the domain of f of x, and then the domain and range of f inverse of x. Okay, so I did a lot of explaining on that one. So now let's try it, and hopefully things will make more sense and we can move a lot quicker through this next problem. Okay, so number 4. Again, it's to the second power, so this tells me that this is a parabola again. And until you get the hang of it as far as restricting the domain, make sure that you graph it. It helps when you see a visual. Not all of us are visual learners. I'm more of an auditory and a steps person when it comes to learning. But when it comes to a graph, especially these, it does help to see a visual. Okay, so this one is the parent function shifted to the right 2 units. So we got to shift it to the right, and that's where the vertex is going to be. And it's a parabola facing up. I don't need to be all technical about how wide or how skinny it is. I don't care about that. Okay, so there's the parabola, but remember, we need to chop off half of it so that its inverse will be a function, because we know that the inverse of a parabola will be a sideways parabola. We know that now. So I'm going to chop off half of it. It doesn't matter. We could chop off the left or the right. Since I chopped off the left on the last problem, let's chop off the right this time. So when I come up with the domain and range, it'll look like this. So f of x, the domain. So I'm chopping off the right half, so I don't want to see that half. So I'm at an x value of 2, but then 2 and the numbers to the left of 2 to get that left side. So x's have to be less than or equal to 2. Okay? What helps remembering which inequality symbol is which, the less than symbol always points to the left. So think left, less than, or less than left. And then the other one's got to be greater than. Okay, that's how I remember it. I could never, ever do the alligator thing. That freaked me out and confused me so bad when I was a kid. All right, the range, the lowest y value we're using is at that minimum there. That's a y value of 0. So y has to be greater than or equal to 0. Okay. So what's cool about this is that we already know what the domain and range is going to be of the inverse, because all we have to do is Freaky Friday this. So I haven't even found the inverse yet, but I already know its domain and range. So the domain and range, we just have to Freaky Friday these. So instead of y greater than or equal to 0, it'll be x greater than or equal to 0. And instead of x less than or equal to 2, it'll be y less than or equal to 2. Isn't that cool? I didn't even find the inverse yet, but I already know its domain and range. Now, if you're having issues on domain and range, I will find an IXL for you guys to practice that, okay? But you got to let me know. All right, so now let's find the inverse. So y equals x minus 2 quantity squared. Changing out f of x for all y. Okay, next step, Freaky Friday. We got to switch their places. So x equals y minus 2 quantity squared. And we need to solve for y. So we have a quantity squared, so we can take a square root on both sides. Okay, here's the tricky part though. We chopped off the right half. That's the positive side. Right is always the positive, left is always the negative. So that means, you know how there would normally be a plus or minus? Well, we chopped off the positive side, so we're just looking at the negative side of that sideways parabola. So I will have negative square root of x equals y minus 2. We'd have to add 2 to both sides. Always put it in front of the sign, so I'm going to flip this around. Y equals 2 minus the square root of x. Okay, and if we do a little t-chart, we can figure out how to graph it. So, well, let's find the function first. So f inverse of x equals 2 minus the square root of x. Okay, so if I do a little mini t-chart, remember I can't plug in negatives into that radical because I don't want imaginary, so the lowest I can go is a 0. So we'll try 0 and 1 and 2. That looks good. If I plug in a 0, the square root of 0 is 0. 2 minus 0 is 2. If I plug in a 1, the square root of 1 is 1. 2 minus 1 is 1. If I plug in a 2, I'm going to have the square root of 2, so I'm not even going to bother with that. So these 2 points should be enough. We know the shape of it. So 0, 2, and 1, 1. Okay, so yep, they look like inverses of each other if I have the diagonal. We have the overlapping little curves there. It will work. All right, so let's go on to the next one. My favorite inverse questions. Now these ones always look so scary to students because they get a little bit confused because they see a table, but they're actually the easiest ones that you could possibly have. Okay, and I did find an IXL on this, so I think I will assign that as part of the homework. So it says use the table below to find the values, and we have x and f of x. Remember, f of x is the same as a y, okay? And it's asking us to find f inverse of -3, f inverse of 5, and f inverse of 9. So remember, we're finding an inverse. So remember, Freaky Friday. Okay, so remember, x and y have to switch places. So f inverse of -3. Well, this means that if we're switching places, if we're using f inverse, that means that this -3 is not an x value, it's a y value. So we have to start backwards. Well, the x value at that y value is a 1. F inverse of 5. So remember, this isn't an x value because we were dealing with an inverse. This must be the y value. So start with a y, and the x value that goes with that y value of 5 is an 8. All right, and then f inverse of 9, remember, this is not an x value. It's got to be a y value because it's an inverse, and it was Freaky Friday. So start with the y value of 9, and what is the x value that goes with it? A 0. Aren't those easy? They're so easy. All right. What do we know about inverses? So let's wrap this up and let's identify everything that we've learned today about inverses. So how do we get them? Well, we know we need to switch the x and the y. And what do we call that? Freaky Friday. Hey, isn't that kind of like that Friday the 13th, wasn't that March 13th when everything got shut down? Wasn't that a Friday the 13th and it was a Freaky Friday? Like, that seriously was the true definition of a Freaky Friday? You guys remember that? Isn't that weird? Especially for that to happen? So weird. All right, their domain and ranges are opposites as well. You Freaky Friday, the domains and ranges also. What about their graphs? Well, if they're inverses, what do they always reflect across? They will reflect across y equals, you guys remember? X. And they have to pass 2 tests. Pass the vertical line test, VLT for vertical line test, and HLT for horizontal line test. How do we fix f of x so that f inverse is a function? Well, we just have to restrict the domain on f of x. Okay, so these are the things that we have learned, and this is what we're going to apply now. Have a good day.